In this video, I'll show you how to conduct basic exploratory data analysis using R, and I'm going to use an example data set that you can go pull off from the course website and then follow along with. And so what I want to talk about first is just what RStudio looks like when you first set this up. So this is a screen capture of what RStudio first looks like, and you have three basic panes. You have the console window here on the left, which is where we can type all our commands in. So if we wanted to say add 1 and 1, we can do 1 plus 1, hit return, and we get 2. So it's our big calculator. It's where we execute all of our commands. Then in the right panel, we have two panels currently. We have this environment tab, which is where we're going to see things that we've saved and named them so that we can use them later in our analysis. And then we have down in the lower right this place where we're going to view most of our plots as well as be able to install and load add-on packages to R. So to begin, what I like to do is write all of my R code in a separate script file, and I've saved one already for this third problem of homework 3 for 107 this term in winter 2015, but if you're watching this some other term or for some other class, well, that's still fine. And what we're going to do first is need to install and load some packages. So there are a couple ways that we can do this. One would be in the command line. I could install a package by typing install.packages and then put the package name in quotes in the parentheses. So mosaic is the first package we want to deal with. But there's an easier way to do this. So I'm going to press escape to ignore that, and then go down here to the bottom right pane and click on the packages tab, and then I can click install. Just type in mosaic, and then I can install that from CRAN, which is a central repository for R packages directly. If you're not using RStudio, you have to do the command line install. Well, there are other places, but I'm not going to display them right now. And you'd have to choose your mirror, which 0 is a fine mirror for that. So now that I've installed this package, I also want to install our color brewer for nicer colors on our plots. And then I click install again. It goes rather quickly, and I'm up and running. Now that those things are installed on the computer, I don't need to install those again, but I will need to load them each and every time I open up a new instance of R. So down here in the packages tab again, you can type in mosaic, and it's going to show you that you have the mosaic package installed. If you just check that, it'll load it. You can see over here on the left, you're seeing all these loading messages, and you can just ignore those. And we also wanted to load in our color brewer, so I'm going to just check that next package next to that. And warning messages overall you can ignore. Right now it says that these packages were built under a newer version of R. I just haven't updated to 3.1.2 yet, but everything will work just fine. One thing, if you're working in the Briggs Computer Lab, you may hit some issues. If you hit any errors while you're trying to install or load these things using this Packages tab of RStudio, then you should go to the install.packages method, or you can load your packages just by simply typing these two highlighted lines into the console. But now that we're up and running with our packages, what we need to do is load the data set. And we do this when we have a comma-separated value file, a CSV, and that's something that we could open up in Excel if we didn't want to use R, but we want to use R for our analysis. So we're going to use this read.csv function that I have written down here on line 23 of my editor window. And this file.choose message in the middle here, it's just going to open up a pop-up so I can go find the data that I've downloaded from the course webpage. So remember, download that data set first, then go find it. Now over here on the left side, you're going to see this arrow pointing to the word smoking. And what we have here is, well, we're going to load in our data, but then R will just ignore it. It'll forget it if we don't store it and give it some name so we can recall it later. And so what I'm doing is I'm saying I'm going to store the file that's specified over here on the right into this object called smoking. So I can run that. So all I have to do is highlight that and click run up here. And it's going to open up a pop-up window. And now I have to go find where I've saved the data. It's in my Math 107 homework folder. and I'm up and running there. And what you see is that we have this smoking object over here on the right pane now under this environment tab, and it says that, hey, there's the smoking data set with 1,691 observations on 12 variables, and that's exactly right. So it looks like it's loaded in properly so far. Another way to check this would be to look at a couple things about it. So we could print the first 6 rows by highlighting the code chunk that we want, clicking run. And you see the first 6 rows here, so things are looking pretty good. So what you can see now is that we have a data set that contains demographic and other information about smokers in the United Kingdom. You may not have gathered that it's about the United Kingdom yet, but it is. And we have 12 variables, and we can see that, okay, gender looks like it's categorical. We have age that's recorded as a numeric variable. We have gross income that's recorded in ranges, so we have a categorical variable again. And this is only giving us a small snapshot. So if you want to look at the entire data set, you can go up to this global environment pane up here and click on the name smoking, and it'll open up what looks like an Excel spreadsheet of your data. And that's a good way to look at the data set as a whole. You can scroll through it very easily and see what is going on there. And right now, I double checked. It looks like everything loaded properly, so we're good to go. Another 2 checks, just to briefly mention, is that you could quickly count the number of rows using nrow, the number of columns using ncol. So I'm just trying to show you what things look like. So when I ran these, notice that it's printing output, but it goes away. It doesn't show up over here in the top right environment panel, so we lose things unless we name them and save them. But now we want to start exploring this data set. And when I started thinking about this, well, I said, well, we have a bunch of categorical variables such as gender, marital status, highest qualification, which would be an education type variable. We have nationality, ethnicity, gross income, region of the United Kingdom, whether or not they smoked, and what type of tobacco they smoked, what type of cigarettes that they smoked specifically. So I wanted to explore those first, and we learned in class that bar charts are a natural way to do that. And since we have the mosaic package loaded, we can use all these nice statements from that. So this first highlighted part here is a way to make a bar chart for gender. Remember, this tilde gender says I'm going to go pull off the gender column. It's case sensitive. You have to be very careful with how you write these things. I'm going to go pull off this column from the data set. And what data set am I going to be looking at? Well, data equals smoking. And I use color equals gray, COL equals gray, because it really just is visually more appealing to me. So if I run that, I'm highlighted on the row already. I just click run. You see that I get a bar chart telling me that there are just under 1,000 females in our data set and just under 800 males in our data set. So that's a good start. We can start to explore these things, and we can work our way through the other categorical variables by simply changing the variable name that's after this tilde, right? And there's nothing magical about this. So we can look at the marital status, but next we've changed the statement a little bit, and now we see that the options are divorced, married, separated, single, and widowed, and we see that the most individuals that fall into a single bin are in the married category, followed by single. And I'm not going to talk about how we can reorder the bars or anything in this. That gets into a little more complicated programming aspects, but we can do this and we can continue to work our way through these variables. I'm not going to do that, but I am going to post my entire R script here on Moodle so that you can go do that. But one thing I do want to show you is what happens when I try to build a bar chart for gross income. So I'm down here, and I'm going to take this horizontal equals true for a minute. And if I just try to make a bar chart the way I have been, you see down here in my plot, I get all of my labels jumbled. And that'll happen sometimes when you have large labels in. So instead of vertical bars, changing those to horizontal would help. So I'm going to undo my change right now. And if you just add this comma horizontal equals true, and we run this line, what you're going to see is that the bars in the bar chart now shift to be horizontal, and that you can read all of these labels much more easily. And that's really going to be a key strategy to help you make bar charts that are readable in general. Now, a couple other customizations that I'll talk about. We'll just go back to gender for an easy categorical variable to talk about. One thing is that you can add colors for each category. And I'm going to use the R color brewer package to do that. So this, instead of color equals gray, I'm doing col equals brewer.pal, n equals 2, comma, name equals dark2. Dark2 is a color palette that is pretty good in terms of perceptual ability of a lot of people, and n equals 2 is the number of categories I have. Now it is going to throw a warning at me because it wants at least 3, but it's not going to be bad. So if I then run this, what you're going to notice is that I have different colors for each category now. It's relatively easy, and if you have different numbers of categories, just change what n is to that number of categories, and you should be fine up to a reasonable number of categories. At 8 or 10, it might start to break, but then you can recycle colors and it should be fine. I've already talked about the horizontal display of this, so I can rotate the bar chart here very easily just by saying horizontal equals true. But the other thing that you might want to do to customize some of these graphics is to add a title, and you do that simply by adding in this main equals something in quotations. So if I run this next chunk, what you're going to see is that the only change here is that I added this main equals gender, or bar chart of gender here, and you're going to see that reflected in the plot. So you can add titles very easily and very quickly, and I really recommend doing that so you can remember exactly what's plotted. Or if you don't want to do that, you could use captions in Microsoft Word that you can copy and paste your graphics into. And at this point, that's a good thing to talk about, how we can, once we have a plot that we're interested in using in our homework or report, how can we get it into Microsoft Word? Well, the easiest way to do that in RStudio is down here in the bottom right panel where you see your plot. There's this export option. You click on export and you can copy it to your clipboard so you can paste it right into Word. So if I press copy clipboard, you can change the size if you'd like, and then you can copy the plot. I'm going to open up Microsoft Word here, a new document, and then all I have to do is paste it directly into Word, and you'll see the plot as it appeared in that preview window. And of course, you can still resize it, drag it around, add a title if you wanted here, though it's easier in R to do, or if you wanted to add a caption, something like that. When you are working on homework assignments from me, you should clearly label what each graphic is. They should be in order in which a question is being asked, and there should also be a description of the plot. So all of your plots should be saved in a Word file, not only to save paper, but also to enable comments and other things to be entered in. So that's one thing to keep in mind. But let's go back to the R session now and carry out a little bit more exploratory data analysis on this data set. So we've talked about one categorical variable in terms of graphical exploration, but we haven't talked about it in terms of summary statistics. And in class, I did talk about using this tally command. We're going to tally the number of individuals that fall into each category. So let's say I wanted to tally the number of males and females that are in this data set, and I want it in different formats. So I can highlight this tally command. If I don't have any format option, like I just changed it to, and I run that, what you're going to see is that I'm just counting. But I can change this to have different formats to give me different things. Something nice to know is that if you're down here in the console, so just click down here in the console, and you press the up arrow on your keyboard, it will return the last command, and you can keep pressing up to see your previous command. But this is really nice if you just want to tweak a command to see how it's working. So instead of a count, maybe you want a proportion, and it can calculate that for you very quickly. And maybe you want that to be a percentage without having to multiply by 100, so you can change the format there again very easily. So this is something to keep in mind, to look at, and to change things to your liking when you're creating these summaries. Having talked about one categorical variable, let's move on to one quantitative variable, and let's start with numeric summaries because that's what we just did for one categorical variable. So now let's look at the variable age in the smoking data set. If you want a quick summary of that variable, the function favstats is a good way to start. It's going to give you the 5-number summary, the mean, the median, the mean, the standard deviation, the number of missing values, the number of values altogether, things like that. So using this tilde again, we're going to pull off that column age in the data set smoking. If I run that, what you're going to see is the output down here in the console. So again, you can see that the minimum age is 16, the median's 48, the maximum is 97. The average age in the data set is pretty close to 50. We have a standard deviation of 18.7 years or so, and we have no missing values on age. As you can see down here, and n again is going to be the number of observations that we actually have in our data set. And we can do this for other variables, again, just by simply changing the name of the variable. So if you want to know, let's look at, well, how much are people smoking on weekends? We can look at the summaries there, and what you're going to notice is that all of a sudden I have missing values. I have 1,270 of them in this data set. And well, why is that? Well, it's because we have non-smokers in our data set, so they have missing values because they're not smoking at all, so they didn't need these pieces of information filled in. But we don't have to worry about them because it's not a mistake. Okay. Another nice thing to know is that we can actually compare groups using favstats as well. So let's go back to age now and think about, does that differ by smoking status? We might just want to look in that and look at some of these comparisons. So we're going to break down age by, so age tilde smoke is break down age by smoking status. So if I highlight that and click run, what you're going to see is that I have two rows in the resulting output down here in the console. I have one row for the group no, they don't smoke, and I have one row for the smoking group. We can add additional facets like that, so instead of breaking it down just by smoking status, we can do age tilde smoke plus gender, and that's break down age by smoking status and gender. So it reads just like a sentence. That's all these formulas are doing, saying what do we want to do, and that's going to help tell us. So if I then highlight that, let's see what it looks like. And as expected, we get 4 rows in the resulting output here because we have non-smoking females, smoking females, non-smoking males, and males that smoke. So those are the rows of that table that we have. You could do something very similar for the amount smoked on weekends. So the amount weekends by smoking status. And what you're going to notice down here in the resulting output is that, well, we had a whole bunch of missing values for non-smokers because they're not smoking on the weekends because they don't smoke at all. So we have a bunch of NAs, which stands for not available, and NaN is not a number. So basically what we're doing is we're trying to find the average of 0 values, which is impossible, the maximum of 0 values, which is impossible. So they're just leaving everything blank. And that explains what's going on there. Okay. And numeric summaries are great, but sometimes we want to explore things graphically. And we've talked about histograms as being a really great way to do that with one quantitative variable. So as I talked about in class, we have this histogram function in R, and let's make a histogram of age. So to start out, let's take away all of the options that we have other than the color gray, just to see what's going on here. So actually, I'll just type a new command up here. So histogram, notice I'm typing in my editor so I don't lose any work. So age, data equals smoking, color equals gray, and this could be blue or green, it doesn't matter. So I get a histogram off the spot. Notice that it has this density right here, and we haven't talked about how to interpret that. So if you would prefer, you can do type equals count, and that will just change that y-axis to counting the number of categories that you have. You could also type in percent there, and that'll be then the percent of the total, so that would give you a relative frequency. Now, I've always told you to change the bin width, or the number of bins that you have, so you can add this width argument. So down here in the next line, the only change here is that the width is equal to 10, so we have 10-year wide bins, and what I just changed it, and so now you see that one bin is equal to 10 years. Now, if I go down here to the bottom right, I could compare these histograms using these arrows, and you can see how they've changed. We have less bins than we used to before. If instead of specifying the width, you wanted to specify the number of bins, what you could do, and I can just copy and paste this to get a new row here, I could do nint to get 10 bins, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, that's not quite right. So I think that's nint now. It's not plural. Yeah, so nint, you can specify the number of bins you want. So do you want 25 bins? It will make them for you, and that's another way to change that. So either change the width or the number of bins and explore how you want to do that. So now we know how to make a histogram in R. We're okay, we can export it. We've already talked about that. So let's talk about box and whisker plots. So to build a box and whisker plot in R, we're going to use this bwplot command. And if you just want a box plot for one variable, you can just do ~age, specify your data set, and then use this pch equals, in quotes, this vertical bar. So if you press shift and the button right above return or enter, depending how it's labeled on your computer, that's what it'll do. And if I run that line now, you're going to see it look exactly like a box plot that we've had in class. This last command that we have there, the pch equals to that bar, well, all that does is draws a line in the center of the box plot. If I deleted that, what you'd see is a dot representing the median instead of a line, and I prefer this representation of box plots. Okay, so now we know how to construct plots for one quantitative variable. What if we want to have a quantitative variable broken down across groups? Well, we can make a histogram like that. And let's say I wanted to make a histogram of age by smoking status. So that's what this next line down here in line 75 does. I use ~age to say I'm going to go pull off that age column. The vertical bar then says break down that column by whatever I'm going to put on the right here. So break down age by smoking status. Everything else remains the same. So if I press run there, what you're going to see is you get two histograms here broken down by a variable. So this is called faceting. So we have a facet for the no smoking group. We have a facet for the smoking group. If you wanted to change that instead to percent, because you see this unbalanced number of individuals here, so you could have percentages broken down by group or within group, so each group would sum to the same. So you can see that now they're being perhaps as being a little bit more comparable. Okay, so that's a way to get a faceted histogram here, or a histogram broken down by group. Now, what if we wanted to do something similar and get side-by-side box plots of the age by smoking status? Well, we just changed the formula here that we give to bwplot. So we say age ~smoke. I'm going to describe age by smoking, or with broken down by smoking status. So that's age ~smoke, and the rest of it remains the same. So if I source that, what you see is I now get side-by-side box plots for that, just like we talked about in class and have looked at in class. You can do this also by breaking down the amount of cigarettes people smoke on the weekends by gender. Maybe that'll be interesting. So we can run that and we get two box plots again side by side. So we can do this with a number of variables, anything we want. So now you can go change this, look at all sorts of variables, and construct these plots. The last plot type that I'll talk about is the scatter plot, and we call that an XY plot here because you're going to be plotting an X coordinate and a Y coordinate. And the example I have here is plotting the amount smoked on the weekends on the Y-axis, tilde amount smoked on the weekdays on the X-axis, so it's the Y variable tilde X variable here. And then again, remember to specify your data set. If I run that, then we see this scatter plot. And what we can see is that we have pretty good agreement. We have this diagonal line here, so the more you smoke on the weekdays, the more you tend to smoke on the weekends. We have a couple extra points above that diagonal, it looks like, so people might tend to smoke just a little bit more on the weekends in general, but it's certainly not true for everybody. If you look at this individual down here, they smoke far more on the weekdays than on the weekends. Okay, so that is how we can make these plots. And the only other thing I want to show you is a potentially easier way to create some of these plots. So first of all, we need to install the manipulate package. So you can run install.packages manipulate, and then load the manipulate package. Okay, so we're up and running there. And then there are 3 different ways. So you give it a data set, this mplot function, you're going to give it a data set, and then you're either going to type in histogram, boxplot, or scatter. Let's see what each does. So if I run it with histogram in there, what you're going to see, well, it makes a histogram in this awful color, but that's what we'll have to deal with. And what we can do here, notice, is that you have this gear or cog or gear sprocket or whatever there. If you click on that, it opens up a manipulation menu. First of all, you can press show expression to show what you should have typed into your screen in order to get that plot. So that's really nice when you're first learning. Another thing that you can look at is that I could change the plot type to density or frequency polygon, but we're going to deal with the histograms mainly. But you can also specify what you want on the x-axis. So any quantitative variable you could choose to build a histogram of, and then you can use this slider to change the number of bins, either more or less bins. So it's a very easy way to customize your histogram just as you want it there. You could add a facet very easily through that drop-down menu, and away you go. Then you could go copy that to your clipboard, resize, and you're done. So that's a really nice way to go. So that's histogram. If you want a histogram, go that direction. So what happens if we use boxplot instead? Well, it's a way to get side-by-side box plots. So you get to choose what you want to plot on your x-axis here. So maybe we want to plot region, and then you're looking at the ages by region here. If instead you want to look at the amount smoked on weekdays, we can change that variable very quickly. We can check this option to flip the coordinates if your labels are getting a little crazy, and other things like that. So it's a really nice option, and you can do this. You can also change it to a scatter plot, relatively easy if that was of interest to you, but it's not always of interest. So boxplot seems to be the way to go. And if you wanted a scatter plot, then, well, why not just type in scatter and it'll pop one up, I'm sure. So now this is age by the amount smoked on weekends, but let's replicate the scatterplot we just created above using this functionality. So our x variable is already set. If we want a quantitative y variable, well, that was our weekends. Notice it just changed here at weekends, oops. So our x variable we actually need to change to weekdays. So when we do that, we get the same plot that we just saw. And again, if you wanted to then tweak that, maybe add a title there, you could press show expression, go over here, just copy that in, paste the line again, and then I could, insert title there, and away we would go. So it's very easy to customize as well using the options that I've already shown you. So going back to the manipulation window, another thing to notice, I have this nice scatter plot. Well, what if I wanted to fit a linear model to that? Well, I could just click linear there, and boom, the regression line is plotted, and it's extremely nice and easy to use. So I hope this makes it a little bit easier to do. I could click show expression there. Of course, this type of functionality is a little cryptic, and I'm not going to worry about that right now, describing that. But I hope this really helps you use R to complete your tasks for exploratory data analysis. So good luck, and I hope you have fun exploring.